Hello everyone. Today I'll be discussing 5 critical concepts in quality management and metrology that are fundamental to ensuring accuracy and reliability in any measurement or testing process. These topics are the difference between validation and verification parameters, measurement of uncertainty, and ISO IC 17025-2017 standard. Understanding these concepts is essential for anyone working in laboratories, especially food laboratories, and quality control or any field requiring precise measurements. So first, let's clarify the distinction between validation and verification. While these terms are often used interchangeably, they have distinct meanings in quality management. Verification answers the question, are we doing things right? It's the process of confirming that a method, equipment, or system meets specified requirements. Think of it as checking against a standard or specification. For example, when you calibrate a thermometer against a known standard, you're verifying its accuracy. Whereas validation, on the other hand, answers, are we doing the right things? It's the confirmation that the method is suitable for its intended purpose and produces reliable results in actual use conditions. Validation goes beyond just meeting specification. It demonstrates that the entire process works correctly in real-world applications. A simple analogy, verification is like checking that your car's speedometer is accurate, while validation is like confirming that your entire navigation system gets you to your destination safely and efficiently. Now, what exactly do we look at during validation? There are several key parameters like accuracy, precision, specificity, selectivity, linearity, range, LOD, LOQ, and robustness. So what is accuracy? Accuracy tells us how close your measurements are to the true value. This tells us if the method gives correct result. For example, if you're spiking 10 ppb on your sample and you're getting a recovery of 80%, and whenever we do validation parameters, we do it in 6 replicates. So in accuracy, suppose you're getting 80%, then 85%, 89%. So the criteria here would be that the RSD of these 6 replicates should lie, it should be less than or equal to 20%, and it should be close to your true value. Then you can say the method is accurate. Now in precision is reproducibility of your results. So this includes repeatability, and repeatability is the same operator and same conditions. And in reproducibility, you use different operators and different days. Here also we do it in 6 replicates. And the main difference between precision and accuracy is that people actually get confused between these two terms because we do the same thing. We run the 6 replicates and we see the recovery. So people get confused, okay, why there are two different terms, accuracy and precision. So the main difference here is that if the method is precise, it doesn't mean it is accurate. Suppose, for example, if you're spiking 10 ppb in your sample, you may get a recovery of 50%, but it would be consistent. You're getting 50, 55, 56. So that method is precise, but it is not accurate then. So this is what is accuracy and precision. In specificity and selectivity, it tells the ability to measure what it's supposed to measure without any interference from other substances. Then you can say your method is specific and selective. In this, we run reagent blank and matrix blank, and we see that there is no other peak eluting from your reagent blank and matrix blank where our analyte peak is eluting. So in linearity, what we do is it is a method that produces results proportional to the concentration or amount across the working range. So we get a linear response. And range is the lowest and the highest concentration where the method performs is acceptable. And in LOD and LOQ, in LOD, the criteria is that the signal to noise ratio should be more than 3. So you're getting the ability of your instrument to detect that your analyte is present in the sample is the LOD, and the criteria for LOD is the signal to noise ratio, it should be more than 3. And in LOQ, the criteria is that the signal to noise ratio should be more than 10. Now why it is like that is that in LOD we can only detect that the analyte is present in the sample, but we cannot measure it. It is not consistent. Like if we are getting 2 ppb concentration, maybe you next time you are getting 3 4, so it is not reliable. You can say only it is detecting ki, okay, there is an analyte. So that is your LOD. So the criteria is that signal to noise ratio should be more than 3. And in LOQ, you can not only detect it, but you can also measure the quantity. So the criteria here is that it should lie between 70 to 120% recovery, and also the signal to noise ratio should be more than 10. Now in robustness, what is robustness? It is the how resistant the method is to small and deliberate variations in conditions. Like you can deliberately change the column temperature or injection volume and see how robust is your method if there is any slight change or variation in the conditions. So these parameters, it is a very vast parameters are there in validation, and they work together to prove that your method is fit for the purpose. Verification parameters are generally simpler and more focused than validation parameters. They typically include calibration checks, accuracy verification, precision check, and working range confirmation. So only these 4 things are checked: linearity, accuracy, precision, and working range. Verification is performed more frequently than validation, often as part of routine quality control. While validation might be done once when establishing a new method, verification happens regularly to ensure ongoing compliance. Now, when you work in a lab, it is essential that you know what is measurement of uncertainty, or MU. So measurement of uncertainty is the dispersion of values that could reasonably be attributed to the measured quantity. Simply, it's a quantitative expression of doubt about your measurement result. Remember, no measurement is perfect. Every measurement has some degree of uncertainty arising from various sources. There could be instrument limitation, like the precision of your measuring device, or environmental conditions like temperature, humidity, or vibration effects, or operator variability, that is differences in technique between two analysts, or sample variation. It could come through inhomogeneity in what you're measuring, or method limitation, that is inherent constraints of the technique used. So measurement uncertainty is a guideline in food laboratory, and you must adhere to international standard, primarily to ISO IEC 17025. So the core international standard for competence of testing and calibration laboratory. What it does, it mandates that laboratory must establish procedures to estimate measurement of uncertainty for all quantitative tests. And this NABL 141 is based on internationally recognized guide to the expression of uncertainty in measurement, that is GUM. It provides a framework for laboratories to systematically identify, evaluate, and combines all the sources of uncertainty to arrive at a final measurement uncertainty value. So your type, your uncertainty can be divided, broadly be classified in two, that is type A evaluation and type B evaluation. So in type A evaluation, it is based on statistical analysis of repeated measurement using the standard deviation to represent variability. It is like the analyst does 6-time extraction and that is injected, and those 6 replicates are checked, and the standard deviation is taken into account. And what else comes under type A? It is environmental conditions, that is changes in temperature, humidity, or instrument limitation or analyst variability. While in type B evaluation, it is based on non-statistical information such as manufacturer specification for equipment, calibration certificate, and published data. So like the uncertainty is established over here. Like it can come from your balance or your micropipette or your glasswares or your drying equipment like oven, water bath, and your CRM materials. So the uncertainty here is established. You have to just take the uncertainty value, and there's a table where you put all your uncertainty, like the type A uncertainty is taken from the standard deviation of your repeatability result, and in type B all the uncertainty that is provided by your external calibration for balance, micropipette, and CRM is taken into account, and these two, type A and type B, is combined, and we get an combined uncertainty value with the 95% confidence level. So for example, a result that might be reported as 25 mg per liter plus minus 0.5 mg per liter, where your true value can lie between 24.5 to 25.5 mg per liter. Now what is this ISO ISC 17025? So it is like a certification that is given to a lab when it passes all the exams, like it has to establish a scope, its competence, then impartiality, the structure of the quality management system, and guidance to ensure the consistent operation of calibration or testing laboratories. It is widely accepted and used by calibration and testing labs to define resource requirement, technical competency, and process requirement and quality management system. This standard, it mainly focuses on risk-based thinking, performance-based requirements, increased flexibility in attaining requirements for processes, and procedures for calibration and testing laboratories. So this ISO ISC is nothing but it is joint standard developed by jointly by International Electrotechnical Commission and International Organization for Standardization. It is a certification that is essential for any lab to issue a calibration certificate or test report to prove the technical competency of the calibration or testing facility. So just remember, in ISO 1725, there are 8 clauses, that is your scope, general requirement, structural requirement, resource requirement, process and management system requirements. And there are sub clauses to it. And it is very interesting to learn all these sub clauses. And it is essential to get certification by this standard. So this is all for today, and I hope you liked the video. And if you have any doubts or question regarding this video, please do drop it in the comment section and I will be happy to answer them. Thank you.